Hello and welcome to today's live webinar, Formative Assessment and Improving Student Achievement. It is with great pleasure that I introduce to you today's panellists, which are Jodie Carruthers, who's a Maths and Science teacher from Safety Base Senior High School in WA, and Jenny Curtis, who is also from WA but teaches at St Mark's Anglican Community School. Not only are Jenny and Jodie brilliant maths educators, but they've also have years of experience of linking mathematics teaching and learning with technology with the aim of improving student learning, which, as you'll agree, fits really well with today's topic, so we're in good hands. During this webinar, if you wish to ask a question or communicate with either myself or the presenters, please use the chat space to do so. In the event that I don't get a chance to answer your question during the session, I certainly will do so after the session via email. Now, I'm sure you would agree that's quite enough from me, and I would like to now hand over to Jodie, who will be starting today's webinar. So, over to you, Jodie.
My desktop. Good evening or good afternoon, depending on whereabouts in Australia you are. We're just getting ready for the sunset to start happening over here, which is lovely. I'm going to take you through an activity to start with and talk about the way we use the power of the TI-Nspire to provide feedback, mainly through a formative process, but it can also be used in a summative process if you wish. The first file we'll look at is called Circles in the Form. I actually might take a little bit of time, make it a little bit bigger for people to see. Now, coming from the Australian curriculum, the reference in the methods course, the reference for the Australian curriculum is listed, the ACM number. And also in Western Australia, we've chosen to give it our own codes because we're absolutely insane. We've got 1.1.21, so just telling you about where it's located. So as you can read, looking at recognising features of the form of a circle. So what I'll be working with my kids is we'll be doing the usual hands-on stuff with the graphs and compasses, rulers, drawing and having a look at what's happening. But what I'd like to do is take the kids on their handhelds through an activity. Now this activity is self-checking, so you don't need to have Navigator. The kids don't need to send the files backwards and forwards to you, so it can just go out directly. So however you get the files to the kids, be it through the docking station or Cradle, or whether you upload them to the internet and have them download it to their own PCs and then connect and share with their calculators, these files work well. This document, in this part, it's a notes page, just gives us information. And the reason the value of R is highlighted there is just to give it a bit of significance, give the radius. The formula, when I click on that, as you can see, is in the dotted box, which is a maths box, which allows it to be interactive. Now here is where everything starts getting interesting. We've got a circle diagram, we've got a small notes page down the bottom with the equation, and then we've got a slider. What the slider will allow us to do is for the kids to take the time to move the slider and have a look at what's happening. Along with this, I'll actually have probably some guided questions as well, just to get the kids to consider what's happening as the value of R changes. Now the cluey ones will be able to look up and see the bit that says radius equals to, and hopefully they'll be able to make some of those judgments themselves. But I can set this as an independent task, and as the kids get on with it, they can do the first part, then it pops up a question page. So what we can do is, what is the effect of changing r in the circle of the equation from 3 to 5? Okay, the ticks come up because the question's been answered before, but I can clear the answers. So I'll send a clear version to the students, and I do, they consider it. Is it going to move the circle 2 units right? So is it a translation, or is it going to change the radius? Is it a square factor? So I'm going to choose B, and the students can check their answer. My current answer is incorrect. They have two options here. They can try again, or I can show the correct answer. Let's try again. B, check the answer. I got it wrong. I'm going to go show correct answer. And it'll bring up a green tick next to the correct answer. As you can see, the power for this is the kids can do the questions and the environment with no fear. I'm not looking at what's happening. Their friends aren't seeing whether they're getting it right or wrong. So they can be comfortable in trial and error, and also comfortable with taking that little bit of a leap, that risky stuff, so they actually learn. This file's only got a couple of examples, but using it with in the classroom, I would actually have 4 or 5 different questions to see if the kid can actually understand the concept. So at the end of it, I can actually ask the student, well, do you understand the concept? And they can actually answer yes or no. I might use a quick poll, or I might just actually thumbs up, thumbs down, using my normal classroom strategies to actually find out whether they've actually understood the concept they've just learned. Building on this one, this is a file I would use as an investigation, and probably a take-home part of an investigation, and building it up. So they're looking at more changes. In this, we've got sliders, but we've got sliders in 2 different forms. We've got the radius one, which is the same as one we had before. Moving backwards and forwards. And we've got 2 other sliders, A and B. And hopefully, after playing around with it, they can actually see the effects of A changing and B changing. If they're unsure, they can tab back and see A is a part after X and B is a part after Y. So they actually see what's happening. The one thing they need to note is the negative sign. That will change what's happening. And once they spend a few minutes playing with that, they need to get some feedback and see if they've actually understood the concept. So if we click back, that equation there is the one on the next page. Then we move across to a question. This is a chance for that formative feedback. The circle of this equation was the effect of changing A. Right this time. The current answer, your current answer is correct. Well done. Effects of changing B. Got that one correct too. I'm doing really well. And that's good. They're multiple choice questions. But that's all I've got at the moment. What I can do now is actually create another one. And that question could be, in the circle equation, what's the effect of changing R? And we've already done that earlier, but let's do it within this context. So I'm actually going to highlight that in my teacher software. And the questions need to be created using the teacher software. we can copy that. We'll go insert a new question, which is not an option. We choose our type of question, custom choice, insert that. I'll paste the question, put R, and I can put my responses. Now, if I want to, I can be really enthusiastic and have a look. Did I give a question similar? No, I didn't. I had specific examples. It changes the size of the circle's radius. If I'm really good, I can actually type it correctly. It makes the circle turn into a square. Two options. Then across on the left, we choose which one's the correct answer. We'll allow a single response because there's only one correct answer there. We right click and we have a look at the question properties. The exam one is one file that's sent out and then collected, whereas a self-check one is one where they get the instant feedback. We'll make this self-check. And the year is 2015. The author can be me. And the copyright, I'm going to make it public domain. You can all share it. Okay. Good. Now I can answer the question. I can check my answer. I just wanted to show the correct answer. I got it wrong. So, as you can see, we can use Nspire and the questions, the self-checking questions, to have a kid investigate a concept and then to have them have an assessment for themselves, really, of their own understanding. And from there, we can share an assessment of what they know. We can move on from there. The kid didn't understand, I would have some alternative work to go with. If they did understand, then I'd be telling them some other tasks to move and further demonstrate their understanding of the topic. So it's that instant feedback that it provides, which is really useful. So let's have a look. I'm actually going to share this across with Jenny next, and Jenny's going to take you through some other stuff. I'll be back after Jenny, and at that stage, I'll put together a variety of questions using the teacher software to give you an idea of some of the things you can do. And it's very powerful, and there are a lot of things you can do. And by making self-checking, you can use them as that formative assessment for kids. You can put them in the exam mode, even then, the questions you can ask to determine the child's understanding, and you can get the feedback by a navigator back, so you can actually have a feeling how the kids are actually travelling with their understanding of the content. And formative and summative assessment, as we know, the timing of it. So some of the questions you can ask and construct can be done before you cover a topic, so you can understand what the students know before you start. And then you can differentiate the learning paths of the students that you're dealing with. Okay, so I'm going to make Jenny the presenter. There'll be a little bit of a lag here. But thanks very much, and I look forward to speaking to you again in 10-15 minutes. Thank you.
Hello. Sorry about the delay. I just wanted to talk a little bit to start off with what formative assessment really is, and then have a look at some of the things we can do on the calculator. Really the goal of formative assessment is to actually monitor student learning, which is quite different from our normal ideas of assessment, where we're evaluating learning. If we are using summative assessment and writing tests and exams and so on, it's really a high-stakes thing for the students, whereas formative assessment is much lower. It's a much lower key type thing, and the students don't feel like they're being judged on every answer that they're giving to something, and that's what we want to look at today. And the research appears to indicate that if we can come up with some effective formative assessment, it really can be a key element in improving the mathematical proficiency of our students, because it provides feedback, just as Jody was using then with the self-checking, that the students can see where they've gone wrong, they can fix it up, and they can move forward in their learning experience. Some of the features of formative assessment probably needs a bit more planning for both the teacher and the students than just setting a test. And we need to be fairly clear about learning intentions. As you'll see as we move through some of the activities I'm going to have a look at, that it can really develop meaningful classroom discussions, and it encourages students to be owners of their own learning and allows them to have a voice. It can give students immediate feedback as well, as you saw with what Jody was doing a few minutes ago. And it also, I've found, allows students to be resources for each other, because they can look at their answers, see where they went wrong, compare it with their partners and so on. So what we're going to start off with is just looking at some algebra concepts and skills, and we're just going to work through some of the things on the calculator. And I think the thing to remember here is it's not the teacher that's providing the feedback, it's actually the calculator. Students are asked to think about what the calculator is doing and to predict what will happen in similar examples. And when they are asked to create their own problems to get a specific answer, they can discuss their answers with other students. The biggest problem for the teacher in this kind of thing is actually collecting the information so that they are informed about student learning. Using Navigator screenshots is a very effective way of doing this. It's an informal way, and we'll talk a bit more about that in the second part when we're actually looking at the Navigator, because the teacher's able to look at one student's screen or the screens of the entire class just to see how they're going. And we're also in this going to ask the students to create their own problem that will give an answer, and then they compare their answers with other students. So this is a really worthwhile thing as well. So if we just click to the calculator now, and we're just going to open up a calculator page. And what I would be asking the students to do would be something like, if we are going to think about, before they press the button, if what the calculator is going to do with A plus A. Now obviously we're looking at sort of lower levels of middle school, but so by doing that on their calculator, they can see what the result can be. And so then we might ask them to do A plus A plus A, and hopefully as you work through a few of these examples, they are going to start to think, well, yeah, I can see what's happening here, and is it going to matter if I use a different letter? They're getting that immediate feedback as to what the what the answer is, because the calculator is giving it to them, and by using the right sort of questioning and comments, we can lead them through seeing exactly what's going on with something like this, and maybe then get them to write down or explain what the calculator is actually doing to get these results. And then once, it doesn't take too long for them to pick up on that, so then we could say, well, what do you think the calculator is going to do with A plus B? And they look at that answer, and if we ask them to respond to it, they'll say things like, didn't work, it hasn't done anything, And we could say, well, what if we used a different letter, if we did C plus D? Or even if we did D plus E plus F? You know, what's happening? What's happening on the calculator? What's different with these ones to the previous ones? And we can start to talk about like terms and unlike terms. And we can just keep on building this process. And we're starting, you know, we can introduce something like G plus G plus G plus then another letter and get them to investigate what happens with that. And just working through those kind of things, hopefully they're going to start to see the patterns, what sort of things add together, what happens when we've got different letters and when we can't add those together. And so then maybe we can take it a step further, like I mentioned in the introduction, and say to them, well, we want you now to write a question that has an answer of 10A. And so then we might want them to come up with something. Now, initially, they're probably going to give us things like A plus A plus A and so on. And we can use the screen capture up here, and I don't have it connected, but I'll just show you if you look up on the left-hand side there where the little camera is. You'll see that it can capture the page. Now, that will just give us a picture of what's on there. If I had this selected to my class where they were all logged into it, I could capture the whole class, or I can just capture one student, and I can have a look at the kind of questions that they're writing that are going to give us that answer of that we wanted of 10A. And so there's a whole lot of learning going on. This is where the collaborative learning will come in, because one student can be comparing theirs with the other student, and they can check on the calculator if it's giving the right answer. And we can do this kind of thing with a lot of different algebraic things. We can do it if we were going to look at subtraction. We could also do it with expanding. If we are teaching them about expanding brackets, or that's what we're going to be starting with, then we can go show them what the calculator can do. Now, to do that, we do need to put a command into the calculator. So we're just on a calculator page. You go to menu, algebra, expand, and we type in what we want to expand. So in this case, it might be x plus 3. And we ask the students to type that into their calculator. And we might do a few of those. So the expand brackets and another one, maybe one that's got a negative sign in it. And let them have a look at a few of these, and then get them to comment on what they think might be happening as they do this. So we can maybe do expand 10 brackets, k subtract 5. And at that point, I think I'd be asking the students to start giving some ideas about what they, the calculator is doing to get those answers. And if we start to get some good responses from that, then I think I might go to something like asking them to write an expression that will expand to, say, 3x plus 9, for example, and get them to think what would they have to put in the brackets for that to be true. And they can try it on the calculator. They can, you know, get it wrong. If it's not working, they can alter the numbers, and that way they're developing probably not a real in-depth understanding of what's going on, but at least they're starting to understand the process of what they're doing. If we wanted to take that a little bit further, and we'll just get this out of the way because it's not actually calculation. Okay, a bit further on, you might like we've done some expanding and they're used to multiplying out brackets. Then we could introduce the idea of factoring expressions. So we could go the same thing, menu, algebra, and factor, and say, okay, well, I might want to factor 3x plus 9, and they will find that that does the total opposite of what's being expanded. And you know, I give them a few of those to do, and that way they start to get the idea that, hey, you know, what I get as an answer when I'm expanding is kind of the total opposite of what I'm doing when I am doing factoring or factorizing. And so it's starting to make them think a little bit more about the processes that they might be using. And we can take this as far as we want to. We can take it to the idea of expanding brackets for trinomials or for quadratic type expressions, and that can be quite useful if we go to our algebra expand again. And so we're going to expand something like x plus 5 multiplied by, and remember between brackets and things we need to make sure that we're putting the brackets, the times in, and we're going to multiply that by x plus 1, and they can have a look at that. Now obviously it's not so obvious as what's going on, but we can talk to the students and they can start to think for themselves a bit more. Hopefully that's what this is encouraging. And once you've done some of that, you might even like to introduce the ones like g plus 1 and g take 1. Make sure we put the expand in the front. So do menu, algebra, expand, and look at what happens when we do that one. Let's fix up these brackets. Okay, still don't think we've got that right. Great. Might start that one again. Okay, so we're going to expand, and we're going to expand g plus 1 times g minus 1. Okay, and start to see what's going on there. Now, I've squished a whole lot of things together there, and obviously you wouldn't do all of that in one lesson. This would be over quite a long period of time, but it's an interesting way to develop some of those concepts, or even just review them and remind students about what's actually going on. And they've got the power of the calculator there to be showing them what's the right answer, and hopefully they can start thinking about where that comes from. Okay, so I'll be back in a little while, and we'll swap back to Jody now to do his next part.
Hi, and welcome back to me. Thanks very much, Jenny. I learned something then, which was wonderful, and was really interesting to hear the approaches you use with your kids, especially like the algebra stuff that you're doing with the calculator. I'd love to be able to use them in the younger years with the kids. Okay, I'm going to get into some nitty-gritty stuff now in terms of using the teacher software to produce a question. You can't do it with the handheld. You actually have to have the software to be able to do it, because here are your page options on the calculator. So you need to go up to Insert a Question. And as you can see, there are multiple types of questions here. We'll start off with a simple one. True, false. Insert. Now across the document toolbox, you've got your usual files, templates, view of the handheld, which is what you use often when you're working with the kids. You've got the different apps or pages, But we really need a little hammer and a spanner, which is good, just to have a look at the details and the properties. It's here where you can configure your question. We're looking for a single response. I think it's going to be a true-false question. I understood. How to spell. Understood. The last question. And look, I've got emails coming off, which I better disconnect. I don't know who I'm going to get them from. I understood the last question. And I can set the correct answer, true or false. Well, in this case, there is no correct answer. We're just getting the feedback from the participant. So you can do that. You can send that out, and you can get the responses back from the participants. Now, if you want to do another question, you go insert question. And custom choice. You can have multiple choice, which gives you the ABCDs, or a custom choice. And here we can have a variety of options. I use this one with my kids a lot. Mr. Crothers is great, awesome. And if you hit enter again, you have a few more options come up. Brilliant. And well, let's be correct. The correct answer is I'm going to choose multiple responses because I think they're all correct. And my students will play around and they'll find out, and they'll disagree with all the answers, but that's okay. It's important for them to discover these things. Now, there, we can insert another question. The equation and expressions. This is where students can use the graphing features of the handheld and be able to see their answer as it comes up. But to do that, we need to include a graph preview. There's the graph preview. And the correct answer here is going to be 2x plus 2. You can have the students show their work part by part. I'm not going to use that at the moment. And on the graph here, I can actually insert my own line, which I'm actually going to insert the line that I want to draw. 2x plus 2, enter. The label comes up. If I really wanted to test the handheld skills early on, I would actually leave that up and see if they can actually work out what is the equation of the line. Drawn on the axes to the right. With question mark. The label or delete. And I would actually change the window settings too. I think we go from -5 to 5, and from -5 to 5. It looks a little bit more realistic. And depending on what level of scaffolding you want to give your kids, you can hide or show a dot grid or a line grid. I'd actually have a line grid there. children actually go to answer the question and they go, oh, I think that's 3x. As they type the line, it actually appears on the axes. Oh no, it's going to go up some. So 3x plus 3, too high. Plus 2. Oh, now it needs a bit more of an angle. Oh, we need to change the slope. Should it be steeper or less steep? Less steep. So let's change the gradient, and there we go. So you can actually take the time to be able to answer the questions. Question property, we can make it self-check. And then we can check our answer. Your current answer is correct. It also says here, equivalent responses are considered correct, which is good. Clear answering question. So if I went, it's going to be 4 divided by 2 times x plus 2. Then that, while not the same as the accepted response I typed in, is equivalent. So it will actually accept that. So when we check our answer, the current answer is correct. So it'll give you those sort of opportunities, which is nice. Let's go to another one. Insert. Question. We can actually just have what is the integral or derivative of something, or what is the equation of the line with a gradient of 4 and a y intercept of 5. So x plus 5, we make sure we've got our accepted response. So from there you can have a straight word without the picture. So we go 4x plus 5. And then we can check our answer, which is correct. Now, if you want to give assistance, including a graph preview, they can actually type in the same thing, 4x plus 5. But they can have a look and see what's happening with the equation they're typing in, or the equation. So far, the true-false, simple multiple choice, doing a function, or a graph, and graphing that while actually being able to see the graph. So we'll do the answers. We'll actually create the graph. The same style there, but you can actually remove that, so you actually be a straight question that they can answer and have that response. Insert. Another question. I'm going to go for a graph. Again, I'm going to have a graph preview. But what I'm going to do, I'm going to insert an image. One of my favourite things to keep the students interested. So I'm going to ask them. I'm going to change the window settings. -5 to 5. Now tab. -5 to 5. What is the equation of the parabola formed by the water from the drinking fountain. And that's good. If I really want, I can move the axes to make it a bit easier. It's fine. Now, if I want to know the answer, I don't actually know the answer off the top of my head. So I would play around with the whole equation myself. There, and 1.5 on. Oops. Then make it negative. That's not too bad. It's going to be out a little bit wider. Kids you go, oh, double? No. A little bit wider, it needs to be smaller, so 0.8. Maybe a little bit higher. 0.6. So there we have it. So as a teacher, I'm going to go Control X and paste that as my answer. Good. So the kids can actually take the time and go through that process themselves. And transform the dilation, translation, the parabola to actually meet up with the equation and get the feedback to understand that they know what they're doing. So that's useful. The use of the images is actually quite good. And that's something they can actually gather themselves, so they can get that instant feedback to see if what they were thinking was correct. So, one last one. I don't use the explanations in text max very often. They're okay using Navigator to get the information back. But you can use numerical input, or drop points, lists. Insert a coordinate position in which students respond with a coordinate. Okay, insert. Include a graph preview. Show a line grid. And you can go what are the coordinates of the given point? And from there, menu. We need to go back to this. Points, lines, point on. There we are, we've got a point. Go back to the toolbox, that's the point 3, 4, and we'll go, I'll go 3, 5. I'll check the answer. No, and we'll show the correct answer. It's 3, 4. So they actually see the correct answer. So as you can see, you can go through all the Cartesian coordinate stuff. You can have a variety of points. You can have what they call point A or point B, so you can have the same diagram and use it multiple times through it. So there's some economies of scale as you move along. Okay, so I'm taking you through some true, false, multiple choice, equations, coordinates, and as you can see from the questions, there are many other types of questions you can use to help generate some of your formative assessment. And equally, it can be used for your summative assessment too, depending on when you're delivering it, what you're trying to find out, whether you're collecting all the answers, or you're using that instant feedback to help reinforce with the students the concepts they're beginning to develop. develop at the time. Okay, that's me just about done. Thanks very much. I'm going to share my desktop back with Jenny and bid you adieu, and I look forward to listening to the rest of Jenny's stuff.
Hello. Okay, I'm going to do something similar to what Jodie's just been talking about, but I'm actually going to look at quick poll and same kind of thing that we're going to be looking at. What I like about quick poll is that it's just very easy to send a simple question off to the students in the class if we've got them connected up to the Navigator set, and they can put in their answer, and very quickly we can draw it back again, or we can capture their screen and so on, just like we've been doing before. So we're going to look at just a few different things from what Jodie did. And so when we go to here, the first one that we're going to have a look at is equation, which is something that he did, but in a slightly different way. And the one that we're going to look at is just one about a multiple choice one, where it says, which of the following is the solution of 3x plus 2 over 5 equal to 7? And I've, if we put the tools on, okay, you'll notice that I have a multiple choice, and it's just a simple response because only one of these answers is correct. And so we would just, as Jodie went through then, they can try by substituting or working something out on pen and paper and work out which of those is going to be the right answer. And the correct answer is the one down here, x equals 11, and so that's hopefully what the students would give us. The next one is still a multiple choice one, but this time it's one that's going to have multiple solutions. So we go to our quick poll, we want equation again. Okay, but this one is okay, let's see this one right again. Okay, this one here, which of the following equations have the same solution for x? So this time for my multiple choice, I'm going to look at multiple responses because more than one of these ones is correct. And in fact, if we look at it, there's 3 of them that are actually correct. And so the students have the option of ticking more than one. So it just gives you a bit of choice when you're doing your multiple choice questions. Okay, so moving on from there. This is only a very simple one, but I really like the situations where it's not a cut and dried answer and where you're giving the students the option of something happening always or sometimes or maybe never. And so I've made a statement and said parabola has 2 x-intercepts. Is this true? Is it true always? Is it true sometimes? Or is it true never? And obviously it's true sometimes, but not always. So our correct answer there would be sometimes. And, you know, that's got kids thinking. They're not just trying to find a number. They're thinking about, okay, what are the properties of a parabola? Is this something that's always true? Well, yeah, it's true sometimes, but it's not always true. That's just a slightly different kind of question to the other ones. Okay, another feature that I really like of the quick poll is the one where it actually gives us the option of coming up with a situation where we want to get an answer, in this case a solution to an equation, okay, and so we're going to insert that, but in this case I want them to show all their work, and you'll see that there's an option here at the bottom that says allow students to show their work. Now what we're going to ask them to do in this one is to solve showing all their working. And that's their instruction. And in here, right, we're putting the equation that they're going to start with. So what they're going to do is solve this equation of 2 brackets y plus 3 is equal to negative 2. Now I've just chosen a very simple, lost our y there, question, but it's the concept can be used in lots of different ways. So the student, that's what they're starting with. And what this enables the students to do is actually put their working in. So their first step possibly is that they're going to go to 2 times y plus 2 times 3, and that's going to be equal to negative 2. And then we press enter, and it gives them the option of another step. And depending on the level of the students, they can show this in different ways, but the next one might be that 2y plus 6 is equal to negative 2. And so we are able to see when the actual process that they're going through. And so then we can have 2y might be equal to, and this would be at the very basic sort of level, 2y is equal to negative 2 minus 6, and 2y equals negative 8, and our final step would be that y is equal to, from there, our final answer is that y is, hang on, I've lost a 2 here somewhere, haven't I? 2y plus 6, there we go. So 2y is equal to negative 8. So my final answer is that y is equal to negative 4. And I really like that particular kind of question, because it's not only are they giving me the answer, but they're also showing all their working. And as I explained before, if we want to see their working, we can just do the capture the class and see all of their working, or we can capture their page. One of the things you can do when you're going to capture a class is to, you can actually set it so that it refreshes every 30 seconds or however often. And so you can be watching the students work as they are working through it and seeing how they're progressing, seeing the ones that have finished, the ones that are still working their way through. So hopefully you have found the things that we've talked about today useful to you, and things that might help you just use the calculators, use the navigator if you have them, and put a bit more into maybe looking at more of the formative assessment and not just the critical summative assessment, which is such a high-stakes thing for the students. One of the things that I really enjoy about these sort of things is that it starts to involve those students that are never going to put their hand up in the classroom. Finding, like my middle year 10 class that I'm teaching, very few of them are prepared to answer questions in class, whereas if they're playing around like this, they're much more prepared to give it a go, and because they don't feel like they're being judged on the answers that they're writing down. So thank you for listening to what we've presented for you today.
Thanks, Jenny. I couldn't agree with you more with regards to your comments about giving a voice to quieter students. Just one moment. I just wanted the opportunity to thank our presenters today. And my slide's coming up slowly. Hopefully you're seeing it now. So thanks to both Jodie and Jenny for a fantastic webinar session. Comments coming through do indicate that the audience have got a lot out of it, and people asking for files. So the recording of today's webinar will be available on demand from Monday, and with that recording will also be the files that Jenny and Jody have shown you today. So we thank you, the participants, for attending today's webinar, and we do value your feedback. So at the conclusion of this webinar, you will be, I suppose, directed